This is Radio Ecoshock with Alex Smith.
This is Radio Ecoshock, the weekly science-based program broadcast by 104 nonprofit radio stations in the United States, Canada, the UK, France, and Australia. I'm Alex Smith. 2020 will be the hottest year ever recorded, and the rate of global warming accelerated in the past 6 or 7 years. That is the latest word from the scientist who warned Congress about global warming in 1988. On December 14, 2020, Dr. James Hansen, former NASA Goddard Space Institute director, released a new post called Global Warming Acceleration. The co-author is Dr. Max Sato from Columbia Earth Institute. Their explanation for the rapid burst of warming we've just gone through may surprise you. The climate shift is speeding up. No wonder the United Nations just called for a wide-ranging declaration of climate emergency from every government, even while the pandemic rages in many countries. We are going to explore a bit of basic climate science to understand why more heat waves, wildfires, and violent weather are striking around the world. We know how difficult 2020 has been in health, in the economy, in politics, and while we were busy with all that, Earth experienced several of the hottest months ever recorded for May, June, September, and November this year. It will be, Hansen Sato say, the hottest year ever seen. But it gets more shocking. This could have been a cooler year. It should have been. The great cooling phenomenon called La Niña was strong in 2020. The sun's power was at minimum levels as part of the solar cycle. Western economies closed down at times, and human emissions were measurably lower than in previous years. A slowdown in planetary warming, but the opposite happened. We must find out why before the strong solar cycle returns, along with the El Niño events that previously set world heat records, like the one in 1997 and 98. If our fossil fuel burning goes back to normal, when any of those natural forces develop, we could be in for a severe climate shock as early as 2025. Earth has warmed more and more over the last 20 years. If 2020 is the hottest, 2016 was the second, 2019 third, followed by 2017, 2015, and 2018. It's all just happened. Every year in the past 5 years has been hotter than anything before. We are not talking about just the Arctic, which was astronomically hotter than anything ever seen during the times of humans. This was the whole world record, a global temperature. That sounds like trouble, and it has been hard for everyone escaping massive wildfires or trying to recover from the back-to-back mega storms that I covered on Radio Ecoshock in my show posted November 25th, 2020. You can find that at ecoshock.org, and it's well worth getting it. But that is just a start. We are at the beginning, with many more waves of heat, violent weather, and agricultural failure. That's food we're talking about here, people. And it's all coming this decade and every decade for at least the next hundreds of years. By changing the atmosphere and trapping heat, scientists discovered only about 4% of our actual impact goes into warming the atmosphere directly. The rest of the new energy that we create mostly goes into the ocean. That harms the existing marine biosphere. It's killing so many species, from plankton to coral to the largest marine mammals. The continual heating of the seas has saved humanity from the true force of solar-captured energy. But that heat will come back out, warming the planet for centuries, no matter what we do. We are committed to strong climate change. The big questions are, how bad will it be? How fast is it arriving? And can we slow down or reverse the warming? And finally, can we survive? As we dig into this alarming announcement from top climate scientists, I owe you a couple of cautions. First of all, I am not a climate scientist. Over the past 15 years, some of the world's best climate scientists have schooled me with their interviews, and I make detailed notes, and I ask some of the dumb questions we all want to know. If I make mistakes, please let me know in my blog comments, an email, or you can contact me at ecoshock.org. Second, Not everyone in the world science community agrees with James Hansen, even though he is a legendary scholar and a pioneer in climate change. This new article appears to be a blog post at this time rather than a peer-reviewed paper. Hansen and Sato offer criticisms of some climate modelers and the Intergovernmental Panel on Climate Change. And here, Hansen's answer as to why the temperature is spiking so high is, I would say, a theory still more open to testing. But these two are teachers who are reaching out beyond the science community to us, ready to speak to the rest of the people, and they must, because there is so little time to avoid disaster, and it will take all humanity to fix it if we can. Here are the first two paragraphs of this December 2020 post by Hansen and Sato. November 2020 was the warmest November in the period of instrumental data, thus jumping 2020 and ahead of 2016 in the 11-month averages. December 2016 was relatively cool, so it is clear that 2020 will slightly edge 2016 for the warmest year, at least in our analysis. The rate of global warming accelerated in the past 6 to 7 years. The deviation of the 5-year running mean from the linear warming is large and persistent. It implies an increase in the net climate forcing and Earth's energy imbalance, which drive global warming, end quote from Hansen and Sato. There was a similar bump, he says, in the heating in the 1980s, and that was caused by CFCs, the chlorofluorocarbons, which not only damage the ozone layer, but they are fantastically powerful greenhouse gases. Pound per pound, CFCs have 10,000 times the heat-trapping ability of carbon dioxide. Fortunately, most production of CFCs was banned in the 1987 Montreal Protocol. Replacements for CFCs are also, sadly, strong global warming gases, but they're less likely to damage the ozone layer. We still have a major problem with refrigerants and climate change. Moving to the last 5 years, our fossil fuel emissions are many times greater than they were in the 1980s. Oil, gas, and coal use kept growing as globalized industry and consumption expanded around the world. Even so, Hansen says, the warming of the last few years, and 2020 in particular, cannot be explained by the continuing growth of emissions alone. Something else is adding to the heat. The authors say, quote, "The greenhouse gas climate forcing growth rate has accelerated in the past decade, but not enough to account for the observed acceleration of the global warming rate." End quote. Well, now we come to a new understanding of how this works. Previously, various scientists and news articles declared there was a time lag somewhere between 10 to 20 years from the time greenhouse gases went into the air until the actual impact is felt. That is because the ocean can capture heat or energy and mix it down below the surface. In this new post, Hansen and Sato say, global warming is driven both by Earth's current energy imbalance and by the recent growth of net climate forcing. The most recent several years have the largest effect on current warming. Their modeling at NASA shows, quote, that about a third of the responses obtained within the first 5 years. The remaining 2/3 is recalcitrant or slow. That is important news for all of us. About a third of the climate impact from our industry, transportation, heating, and all that shows up within 5 years. The other 2/3 will mostly mix down into the ocean to reappear later this century and in many centuries to come. If we were comfortable that the worst impacts would show up long after we are dead, think again. Obviously, each year's additional greenhouse gases are added to the previous year, and all previous years, before that going right back to the beginning of the industrial age. The cumulative carbon is not the exact same molecules from our stacks and tailpipes. Okay, it goes through a carbon cycle that includes plants, but the totals grow and grow. The parts per million level of CO2 in the atmosphere was recently measured at 417 parts per million. It has gotten higher than that even for a short period. The last time Earth was at 350 parts per million carbon dioxide was around 1985. That is the level James Hansen says is required to have ice at the poles and the climate that you and I evolved in. Somehow, we need to go back to 350 parts per million or less, but that is another whole topic. Hansen and Sato continue, we know that if only forcing changes were the greenhouse gases and the sun, there would be no acceleration of global warming in the past 5 years. Indeed, there should be a decrease in the warming rate. The real-world acceleration tells us that there must be another forcing, which is unmeasured. There is only one good candidate, aerosols. Although NASA chose not to measure the aerosol climate forcing, some aerosol models suggest that global aerosol amount has decreased in the past decade, so he's saying that pollution has gone down. They are not saying that the world should have cooled in the last 5 years. The warming, of course, is because we continue to push more greenhouse gases into the atmosphere. But the rate of warming is even greater than expected from those emissions. Why? They conclude the only explanation is we have less pollution. There are various ways pollution can cool the planet. Smog can block sun from reaching the surface of the land or the ocean. Burning fossil fuels also releases tiny specks of sulfates, which can reflect the sun's energy back into space before it reaches us. In the early years of this century, great clouds of smog, mostly from coal, but also oil and even cooking, added a darkening layer over massive areas of North India and China. The pollution is still killing countless millions of people around the world, but there has been a lot of public pressure on governments to clean up the air. In North America and Europe, there is still a lot of pollution, but far less than in the 1970s when the Clean Air Act and similar legislation in Europe slashed pollution rates. The killer clouds of smog hanging over major Chinese cities in recent decades was legendary, but in recent years, China has taken very aggressive action to clean up the air. Coal burning is on the decline worldwide, reducing pollution greatly. Solar, wind, and electric cars are beginning to decrease airborne particles, which scientists call aerosols. In medieval stories, Dr. Faustus makes a bargain with the devil called Mephistopheles. He sells his soul, in a few years' time, to get answers about the universe now. Hansen and Sato say, quote, the Faustian bargain. Humans have enjoyed the fruits of the Industrial Revolution and avoided a large cost in climate change, as aerosol cooling has mitigated greenhouse warming. Payment comes due when humanity realizes it cannot tolerate the further exponential growth of air pollution that would be needed for the continued mitigation of global warming. End quote. Here Hansen and Sato return to their case made over several years that aerosol cooling is much greater than estimates used in IPCC climate models. In science talk, all this is measured in watts per square meter, generally as solar energy. If you do not use metric measurements, a square meter is about 10.7 square feet. So picture the energy of a 1-watt light bulb illuminating that space. That's a rough way to picture watts per square meter. Sometimes scientists also use the joule, a measurement of energy named after the English physicist James Prescott Joule. 1 watt per square meter equals 1 joule. It is not much energy, but if you increase the solar power reaching the Earth just a little and spread that over the entire surface of the globe, that becomes a massive amount of energy. It is measured in zettajoules, ZJ, which is the energy of sextillion joules, or 10 with 21 zeros after it. So how much has the aerosol pollution cooled the planet? Recent IPCC reports and climate models assume aerosols cooled the planet in the range of about 0.5 watts per square meter up to 1 watt per square meter. Of course, we want to know, well, what does that mean? According to Richard Schiffman at the Yale blog E360, he says, an international team of scientists has quantified that cooling effect, saying the Earth would be 0.5 to 1.1 degrees C, or 0.9 to 2 degrees Fahrenheit, warmer if that pollution were to suddenly disappear. So it looks like watts per square meter and temperature in centigrade are the same thing. Sadly, things are more complicated than that. For example, some calculate that if 3.5 watts per square meter more energy landed at the surface, Earth would warm by about 1.5 degrees C. We won't go into the many factors now, it's too complicated. There is a major paper just published in September 2020 with Hansen as a co-author, and it updates the essentials of climate change, and I hope to cover that soon. The important thing is, our pollution has been cooling us. The general run of science, leading to reports by the Intergovernmental Panel on Climate Change, says we have been cooled by somewhere between half a degree to just over 1 degree C. Even with that blanket of reflective smog, we have warmed the Earth by at least 1 degree C, almost 2 degrees Fahrenheit. And the results? They're already grim, with almost half of Australia's broadleaf forest burning last year alone. And the heat waves, the hurricanes, you know the rest. If we cleaned up pollution completely, this planet would already be past the 2 degrees of warming which we supposedly can tolerate according to the officials. Pollution is being reduced, and it can dribble down to almost nothing if world industry and transportation were to suddenly shut down. That just happened, of course, in many countries due to the pandemic. It could also occur in an economic meltdown or widespread grid failures. Maybe the aerosol problem turns out worse than the IPCC science community think. Hansen and Sato say the IPCC and other climate modelers have gravely underestimated the protection we had from pollution. In 2011, Hansen and other authors published a paper showing aerosol cooling was really about 1.6 watts per square meter, 1/3 higher than the standard assessment. It might be possible that if pollution stops and is rained out in a few weeks, planet Earth could already be approaching 3 degrees C of global warming. We may already be in a disastrous state, but the impacts have been hidden by aerosol pollution. We don't know for sure. Hansen and Sato say of this, our faustian bargain with aerosols, they say, is it important? Yes. It means that the little blip of extra warming that we got in the last 5 years is only a down payment on the penalty that young people will pay for our faustian bargain. Mephistopheles is coming, but it is our grandchildren that he will be dragging off. And that comes from Hansen and Sato. Hansen, the longtime NASA space expert, says we need to settle this big difference about the cooling power of aerosols. He describes a new satellite monitoring program to find out for sure. Considering our civilization is at stake, it is shocking that we don't know. Maybe the spurt of warming in 2020 was just because we added so many more greenhouse gases. Hansen and Sato investigate that. They agree there is a decline in the increase of greenhouse gases in 2020, I think, due to the pandemic. The authors predict the increase of warming gases will drop down a little bit more in 2021 due to the strong La Niña now underway. However, methane is shooting up, presumably as a result of fracking, they say, increased venting at oil wells, and global warming feedbacks from warming wetlands and permafrost, end quote. Because methane, known chemically as CH4, is anywhere from 10 to 100 times more powerful as a greenhouse gas than carbon dioxide, it is possible the increase in methane has compensated for lower carbon dioxide emissions during the pandemic, keeping us on a steep track upward with more warming gases. The other major warming gas is nitrous oxide, often from agriculture. Those emissions are growing slowly, these two authors say. They conclude, slower CO2 growth offsets increased methane and nitrous oxide growth, so our estimate for the added greenhouse gas forcing in 2020 is essentially the same as in 2019. But could it just be all from a change in the sun? Quoting from Hansen and Sato, one more thing. Remember the cry of the climate deniers? Many of them were counting on the sun to go into a new prolonged Maunder minimum. That was possible, although the resulting negative climate forcing or cooling would be small compared with the human-made greenhouse gas forcing. It turns out that, on the contrary, we are now entering the next solar cycle. Solar minimum was late 2019. The uptick in the irradiance is small so far, but the predictions from some solar models are that the coming maximum will be a strong one. The impact of solar irradiance on global temperature lags solar irradiance by 1 to 2 years, so we're still at the point where we're getting maximum cooling from the solar cycle. Maximum added push of the solar cycle towards a warmer climate will be in the mid-decade, i.e. in about 5 years. Global temperature prognostication, 2021 will be cooler than 2020 because of the lagged effect of the current strong La Niña. When the next global El Niño occurs, perhaps around mid-decade, hang on to your hat. Global emissions of GHGs had better be trending down by then. So say James Hansen and Max Sato in their paper, actually their blog post, released in December 2020. And they're saying that 2021 might be a bit cooler than 2020, but because of our continuous addition of greenhouse gases, it could still be among the top 5 hottest climate years ever. As our recent guests Kevin Trenberth and Will Steffen told us, human-made greenhouse gases have overwhelmed La Niña and El Niño to become the driving force of climate change. Public demand to breathe cleaner air is very strong. We have the technology to do it. There is much more warming coming as we remove the cooling layer of smog, and that warming could come much faster than increases from our fossil fuel burning, because those aerosols don't stay in the air for very long. Add in some strong extrasolar heat as part of the natural cycle of the sun, and the inevitable El Niño that will come, and yes, some year around 2025 could be the breaking point. Then coping with climate change will be the number one struggle for all governments, for all economies, and for all of us. The climate action needed to happen during the 1990s if we wanted to stay around 350 parts per million. Hansen estimates it will cost trillions and trillions of dollars, and it will probably take years and years if we can ever get back to around 350 parts per million and the world that we need. At this late date, we have the climate emergency. That is not just a phrase or an activist gimmick. The climate emergency will kill millions more people than the epidemic ever will. An unstable climate will derail all our lives, making everything harder or even impossible. The single largest threat to everything we love and that we need is simply climate change. If we do not solve that in time, I fear nothing else will matter. I'm Alex Smith. Thank you for listening to Radio Ecoshock. Please check out my blog at ecoshock.org, where I have a lot more information for you, and all my past radio programs are there for free.
You're listening to Ecoshock Radio for the world.